Hey guys, so today we're going to go a little further into factoring out the GCF because once we factor out the GCF for the next two examples, you're going to be able to further factor what's in the parentheses. So make sure that you went over factoring quadratic equations, factoring a difference of squares. So those are in the previous tutorials. So from here, I'm just going to get started for number 3. Notice that we can't find a GCF with the coefficients because, well, the first one is just 1. So there's nothing both can be divided by other than 1. So we're not going to write that down. But between the subtraction sign, the two terms do have x, and they have at least 3 x's. So you always go, if they both have the same variable, you go with the one with the lowest exponent. So if I have x to the third power, I'm going to write down what happens if I factor or divide out x to the third power out of each term. So if I take x to the 5th power and I divide out x to the third power, remember when you divide like bases, you subtract the exponents, numerator minus denominator, and that'll give you x squared. The next term is negative 121 x to the third power, and if I divide out x to the third power, which is my GCF, the exponents add up to 0, which again, anything with an exponent of 0 is just 1. 1 times negative 121 is just negative 121. Now, inside of the parentheses, you have what's called a difference of squares. The most difficult part of factoring a difference of squares is recognizing it. 1, it's a difference, so subtraction, and it's 2 perfect squares, meaning I can square root each one of them perfectly. So again, if you haven't covered that tutorial, make sure you go over difference of perfect squares. So I'm going to square root each one of these. Remember, when you factor a difference of perfect squares, one is always plus, one is always minus. If I factor, or if I take the square root of x squared, it would just give me x to the first power. Why is that? Because if I have x squared, a square root is nothing more than a power of 1/2, just like a cube root is a power of 1/3, fourth root is a power of 1/4, so on and so forth. And earlier in Module 1, we were taught when we have a power to a power, properties of rational exponents. When we have a power to a power, we multiply. 2 times 1/2 is just 1. Half of 2 is 1. So that's where I got the x to the first power. And then remember, 1 is plus, 1 is minus. So that already is used for the difference. So the subtraction sign, difference of perfect squares. So you're not taking the square root of negative 121. You're taking the square root of 121. This formula works only for difference of perfect squares, meaning it has to be subtraction. So it's already taken into account into the shortcut method. So the square root of 121 is 11. So that means each parentheses ends with 11. And that's pretty much it. Inside of the parentheses cannot be factored any further. And if we look at number 4, strangely enough, there's no GCF. This is x to the 4th. This second term doesn't have an x at all. But if you look, it is a difference, and I can take the square root of each one of them perfectly. So if I were to take the square root of x to the 4th, again, anything that is a square root just has a power of 1/2. So if I took a power to a power and multiplied it, 4 times 1/2 is just 2. So that means if I take the square root of x to the 4th power, using my shortcut method for difference of perfect squares, each parentheses will start off with x squared. Again, one parentheses always says plus, one says minus. And then the square root of 81 is 9. Don't circle it yet. We're not done. So second parentheses, you actually have another difference of 2 perfect squares, meaning I could take the square root of each one of them perfectly, and it is a difference, meaning subtraction. So I'm going to make 2 more parentheses. The square root of x squared, which we've already seen, is just x. One parentheses is always plus, one is minus, and then the square root of 9 is 3. Now the first parentheses is not a difference of perfect squares because it's got a plus sign between the two terms. So all I'm going to do is bring that down. and now nothing can be further factored. So this would be my final answer. All right, guys, hope this helps.